Hello. Today we're talking about measures of center and what that means, how to find them, how to use them. So, first let's take a look on the left, what a measure of center is. And before we get there, it's about our goals for today. It says, or understand the measures of center, the different ones, and kind of their strengths and weaknesses, and also be able to find these measures of center with a data set. So, let's first off talk about what the measures of center are. So, the most common ones, and what a measure of center is to begin with. So, a measure of center, as it says, is the number kind of in the middle of a data set. Okay. Examples would include, we're talking about people, either men or women or combined, what the average height of everyone is, or the average, it says the average income of a population. Now, when you're talking about a population, any kind of a group, and this one's population can be a population of people, things, numbers, whatever. You have to be careful about using one number to describe everything. But often we do that for simplicity and to be able to compare populations to each other. So here, the measure of center, as it says, once again, is something trying to kind of estimate where the middle of the data is. So most common ones, and the most common one you're most familiar with, is the arithmetic mean or just the mean or the average of a set of data. And as you sure mostly know, it's found by you add all the data values together and then divide by the total number of data values to get the average, and that gives you a center. And so this center, then you think of the mean as kind of like a balance point. So you ever try to balance a pencil on your finger, something like that, long ways, then you know the point where it balances, that's the balance point, that's the average, that's the mean. And the idea of a mean in space is very important in lots of other areas. For example, like a ship needs to be balanced from side to side so it doesn't tip one way or the other. Or an airplane also has to be balanced from side to side and also back to front. Okay, so doesn't cause any problems. So that's the mean. That's the most common one, and that's one you're probably most familiar with. Now, another common, probably the second most common one is the median. It says the median of a data set is also a measure of the center of the value. So how to find the mean is you take your data values and put them all in order from least to greatest. Then, basically, the median is the number in the middle. So it's not really determined by the actual values of the data so much as it is by the position it is in the data. So as this says, if you have an odd number of data, it's exactly the number right in the middle. If you have an even number of the data, then what you do is you actually average the two middle numbers, and then that gives you your median. Now, another one is something called the mode. So the mode of a data set is the number that occurs with the greatest frequencies, the number that occurs most often. And it says also data doesn't have to have any mode at all. It's possible no value may occur more than once. You can also have more than one mode. So some values may occur multiple times and maybe the same number of times. So you can have more than one mode. You have two modes, something that's called bimodal, for example, but you can have more than one mode. You can have no mode or just one mode. Now, a mode is also useful that it can also be used for data in which mean or median can't be used. For example, people are going to become parents, often want to know what the most popular baby name is. That would give you a median, or I think that would be a mode. Okay. And I just realized I made a little typo right there. I can fix that right there. Good. So a mode, for example, is like the most common baby name would be a mode. Or for example, car companies, they often want to know what the most popular or the best selling car color is. So that's also a mode. And the final one we're adding, we don't really use it very much, but something called a mid-range. And so the mid-range of the data set is the measure of center, is the value midway between the maximum and minimum values of the data set. And basically what you do then is essentially you're essentially averaging your highest and lowest values. It's the average of those two. So you add those values up and divide by 2. As it says, it's rarely used because since it's only based on those minimum maximum values, it's sensitive to the extremes. So as long as you have the same highest values, highest and lowest value, you can change the data in the middle any way you want, and you still have the same mid-range. Now, one advantage is it's easy to find, but the disadvantage is that it's not very useful because it only gives you information about the highest and lowest value. And finally, a weighted mean is computed when based on different x values or your data inputs are assigned different weights. And a common example of this is a GPA, which we'll do an example of that in a moment. And one more thing before we get to some ideas and look at some examples are the idea of outliers. Now, a data outlier It says it's a number that's far away from most of the other values, either high or low. So it's typically, it could be one outlier, it could be a few. Numbers are just kind of, the reason called outliers, they lie outside the bulk of the data. Okay. A lot of times, if you kind of plot the data in some way, they'll show up. Okay. It's a data that's really far away from the bulk of your data, either high or low. And there can't be more than one outlier. Now, why this is important is that, as we'll see, means are affected by outliers. They can be pulled in that direction, but medians and modes are not. So let's come over to the right, and while we look at these values, let's take a look at some examples, kind of explain this a bit further. So first off, let's imagine we have a distribution, and let's say here, let's start off with the distribution of adult heights. So the distribution of adult heights of adults. I'm having trouble writing this point. In the US. Now, let's say that our average or our mean right now I'm making this up, but let's say it's close to this. Let's say the average is going to be, say, 5 feet 6, or that'd be 66 inches tall for men and women. Okay. I'm not sure if that's right, but that's close enough for example. So let's think about a distribution of that. So we think about plotting it along this axis. So along this axis, we have our height. And along this axis, we have the frequency. So this is the frequency. Now, actual height is something we'll talk about in the future, is that height follows something called like a bell-shaped curve or normal distribution. It looks like something like this, where it's kind of a symmetric distribution. Okay. So from right in the middle here, it looks the same on either side. Okay. Now mine drawing doesn't exactly, but you get the idea. Okay. Now what's going on here is, remember what this distribution tells us, that where this particular height is, this essentially y value, this frequency, or the number of people with that height. Okay. And so that's, as we'll see, this is the average, which for this one made up to be 66 inches tall, about 5 feet 6 inches tall. Okay. And so what happens then is, you go further away from the average height, you have fewer people that are, for example, right here, let's say this is 6 feet tall right here. Right. At this point, you have fewer people 6 feet tall than you had at the average height. Go over here, maybe this is 5 feet tall. You have fewer people who are 5 feet tall than are average. Okay. Then you keep on going further out in this direction for taller and taller people. We have a smaller number of people who are taller and taller, until over here you get the really tallest, just a tiny number of really, really tall people. And over here, the same idea. As we go further in this direction, we have a fewer number of people who are shorter, until over here you get the really shortest people. Now, a frequency distribution like this could be represented with a box comparison is a histogram. But if you have a really, really large population, you can almost make it look like it's continuous like this, where imagine each, if I just draw a line here, each vertical line just is like a really, really thin box. Okay. Now what we'll see, if this distribution is symmetric, like this one is, so symmetric about the mean, means it's a mirror image on one side of the mean is on the other. Okay, then this spot right here, once again, this is our average or our mean. Like, let me write it as a mean. This value right in the middle is our mean. It's also the same as our median. Okay, because that's the middle value. Think about putting all these heights in order from smallest to greatest. The median's number right in the middle. It's also the same right here. Okay, and this is also the mode. Okay, it's the most frequently occurring value. Okay, should be the top of the hill. Once again, my drawing doesn't show that exactly, but that's the idea. So this, once again, being a symmetric distribution like this, your mean, median, and mode are all at the same place. Now, instead, this time next, let's think about the distribution of incomes. Okay, and think of those in dollars. Now, we don't expect that graph to look exactly the same. There could be some similarities. There will be some important differences, and we're going to talk about those. So once again, on this scale, we have the income in dollars. And over here, we have the frequency, or the number of people for each value here in income, the number of people who make that income. Now, let's think about this. Now, in terms of incomes, if this is 0 here, no one's going to be making less than 0. Okay, so it may probably won't start exactly at 0, it may start close to that. Okay, and what this would generally look like is something kind of like this. Now, if you notice, that's a different shape than the height distribution. Okay, and here I'm not going to make up a value for the median income or the income. We don't need to know what it is. But what's different here is that, once again, no one's going to make 0. In fact, most people, like, use the minimum wage, have to make at least something greater than 0. But it's not a symmetric distribution, because over here you have some people who make a lot of money. Okay, for example, like actors like Tom Cruise, or athletes like LeBron James. People make a lot every year, but then you still have kind of the bulk of people making right in here. Now, in this case, with a symmetric distribution like this, as we said, our mean, median, and mode are all right here in the middle. That's not going to be true in this case. Okay, now our mode is going to be right here. Okay, that's the most frequently occurring value, so the most frequently occurring income. Okay, but what will happen then is our median will be shifted this way. Maybe not that much. Okay, but our median, say, right here. What's affected the most is our mean. So once again, this is our mode, this is our median, and then our mean is right here. And we once again mentioned the value of outliers. What happens is that these people making these really, really, really large incomes, maybe millions, tens, hundreds of millions of dollars a year, is basically, those are outliers. Those are, see, they're really far away. They're not really that representative of the bulk of the distribution, what most people make. And so what happens is that with the mean, it actually pulls, those outliers pull the mean in that direction. Once again, think of a mean as a balance point. That's the same is true here. So think about where you want to balance this distribution, is get balanced right in the middle. However, this one, because of these outliers pulling in this direction, it pulls your mean that way, so your balance point moves in that direction. Okay, now median is not affected by outliers. It might be somewhere right about here, probably not the same place as the mode, but basically, once again, if you add up, put up all your numbers, all their incomes in order, and find the middle one, it's going to be maybe right here. But the mean is affected by these outliers, and so that is the main disadvantage of the mean. Okay, after saying all that, then this just kind of gives you an idea of what these things might look like in a distribution. Now, let's actually work some examples. Okay, let's say we example data sets, and let's find these. So, number one, let's say I have this data set. So I have 10 values, so 53, 61, 61, 61, and these are also in order. That should make life easier. 68, then 70, 70, 74, 75, and 77. Okay, so let's imagine maybe these are test scores. So let's find these, except for the weighted means, that doesn't apply here because all our grades are weighted the same. Let's find these, the mean, median, mode, and mid-range. Okay, I'm not necessarily going to do them in that order. So first one, let's find the mode. Let's find the easy ones first. Remember, the mode is the most frequently occurring value. So if you look, and once again, that doesn't have to be a mode. And there can be more than one mode. As we see, the number 61 occurs 3 times. Number 70 occurs 2 times. And all the other values only occur once. So our mode is 61. It's the most frequently occurring value. The mid-range, which once again, that's one, mid-range is something you're not going to use very often. But the way we find it is we're going to do 53. It's the average of your extreme values. The minimum value is 53 plus the highest value is 77 divided by 2. If we just calculate that, so that's going to be, should be 130 divided by 2, and that would be 65. So that's our mid-range. Now remember, let's review just a moment. The mode is the most frequently occurring value. And once again, there can be more than one mode or no mode. The mid-range just takes into, just looks at the difference. It's just averaging the highest and lowest values. Now, if we changed all these values in between, as long as they're still not the highest or lowest, we'd have the same mid-range. So if I made all these values 61 or made all of them 70, okay, then that would still be the same mid-range. That's one of the reasons why it's not used, although it is easy to calculate. It's not used very much because it's often very sensitive to just what those particular highest and lowest values are. Now, let's find the mean. So the mean, once again, is you're going to sum up, and this is a Greek letter sigma. Often in math means sum. We're going to sum these, or I'll call it the x's. Our x's are data values. Okay, we're going to divide by the number of them. Okay, however many we have. That's going to be n. Okay, the number of data values. Now, I've already done the sum. So the sum, if we take all these and add them all up, and you should verify this on your own, it should be 670. Then the number of data values is 10. Of course, that's easy to divide. That's going to be 67. Okay, so that's our mean. That's our average test score. Now, let's find our median test score. Okay, now, in this case, actually, I'll make these parentheses. So in this case, we have an even number. So n equals 10 is even. So what we're going to do in that case, as we said, for an even number, we're going to average the middle values. 2 values in the middle. Okay, so here are the first 5 data values. Here are the second 5. So we're going to average these 2. So then the median is equal to 68 plus 70 divided by 2. Because once again, we count up to 5. We have even data set numbers. So the first 5 in here, the second 5 start here. So the middle, our median is going to be in between, halfway in between these 2. So 68 plus 70. You can check this on your own. Divide that by 2. That's 138. And that is going to be 69. Okay, so these are our measures of center for this particular data set. Okay, so once again, this is our mode is 61. Our mid-range is 65, which once again only depends on the lowest and highest values. Our mean is 67. That's getting from adding them all up and dividing by the number. And then the median is 69. Okay. Now, one thing I should mention here, as I said before, is you'll have to be careful about trying to, always have to take caution in trying to describe a data set, entire data set, by just one number, even if it is the middle number. Essentially, that's what we're trying to find. But, and we said there are drawbacks to these. In some, for example, the median can be affected by outliers. But the nice thing now is currently we have computers and spreadsheet systems like Microsoft Excel, where you can easily calculate all these. You can get a better picture of what kind of gives you an idea of the middle of the data. Now, let's do a similar example, number 2. I'll do the same as number 1, the same data set, but I'm going to include a value. A value of 10. So if this was, fortunately, if this was a set of exam scores or test scores, then maybe someone had a really bad day and got a 10. Let's see what effect that has on our data set. So once again, we have the same data set, except now it's also include the value of 10, which should be down at the bottom. Okay. So I suppose I can just rewrite my data. So 10 and then 53, 61, 61, 61, 68, and then 70, 70, 74, 75, and 77. Okay, now let's see what changes, if anything. As you can see, our mode in this particular case doesn't change. Okay, the mode is still 61. Okay, because in this particular case, that hasn't affected the most frequently occurring number. The mid-range will now change. Okay, so now it's going to be 10 plus 77. So the minimum number plus the maximum number divided by 2. And if we do that, that's going to be 87 divided by 2, which is going to be 43.5. Already we can see that's a big difference. The mid-range here was 65. Now it's 43.5. And as you can expect, this number here, we consider this to be an outlier. It's an outlier because it's very far away from the bulk of the other data. Okay, the bulk of our data, the rest of the data goes, as you can see, between 53 and 77. This is really far away from that. That makes it an outlier, and we'll see the effect that has. Now, once again, that was the mid-range. Already see the mid-range is quite a bit different. It's very sensitive to the outliers. The mean, once again, do the same thing. So this time it's going to be the sum. Now, actually, if you notice the sum of our problem before was 670. Now we're just adding a 10 to that. So that's going to be 680 divided by, but this time divided not by 10, but by 11. And so we now have 11 values. So we calculate that. So 680 divided by 11 is, I'll round this off, this is approximately 61.82. Okay, so now we can see that's a big difference from going from 67, our previous mean, without that value, lowest value, now to 61, or almost 62. Finally, the median. Okay, all right, so it wrote mean twice, so the median now this time I have an odd number of values, so our n equals 11, which is odd. So the median is the middle number. So we just go through and find the middle number. So now we have 11 values. So if we count off the first 5, okay, so 1, 2, 3, 4, 5. We have the last 5 here, 1, 2, 3, 4, 5. So the middle number is actually 68. So that is our median. Okay, so let's see what happens. So by adding this really low value, this outlier, the mode didn't change in this case, because that wasn't, it didn't affect the mode. It wasn't one of our previous numbers. The mid-range changed quite a bit because the mid-range is based only on the lowest and highest values. So it's affected by outliers. The mean is also definitely affected by outliers. So basically having this lowest value pulled our mean in that direction. Like the distributions I showed above with the income, outliers tend to pull the mean in the direction of the outlier. And then finally, the median changed very little. Previously, the middle number in order was 69, averaging 68 and 70. In this case, it's just 68. So that is one of the nice things about the median. The median is not sensitive to outliers. That's one of the reasons why it's often is preferred as a measure of the center, especially if you have a distribution that is skewed in such a way like this one. It was called a skewed distribution, pulled in one way or the other by an outlier or group of outliers. Now, the median is not perfect either, because once again, doesn't actually take the values of the data into account. It only takes into account where the order of the data. So let's look at another example. Let's make this number 3. Let's say these were maybe course evaluations. Okay, just do a quick example. So this might be kind of unrealistic. Let's say course evaluations. So some of you'd often take the end of courses to evaluate your instructor and evaluate the course. And often those are like on a 1 to 5 scale. Okay, so 1 being the worst, 5 being the best. Imagine you had these evaluations. So I'm not going to do too many just to make a point. Let's say you have a 1. Once you put these in order, 1, 1, 1, 2. But then you had 5, 5, 5, 5, and 5. Okay, so you have a lot of people who score the class really highly, and then a bunch of other people, who scored it pretty low. Okay, now this, let's find out. Let's do once again. Let's not worry about the mode or median, because you can find those, or mid-range. The mean. Okay, so there are going to be 9 values there, and let's see, we're adding that, so it's 25, 27. Okay, nice. It would be 30 divided by 9. Okay, that is about 3.33. Okay, so that's our mean course evaluation. But now what happens? See what happens with the median. Once again, the median is the middle number, so we have 9 values. So count up our middle number is right here, which is 5. So you ask yourself here, which one gives a better representation of kind of the middle of the data? Give you more information about the data. Okay, if you saw that your median was 5, you might think most everyone gave it a 5, which in this case is not true. In fact, if like a course evaluation like this, or some other kind of evaluation like on a scale like this, if over half the people give it the highest score, then that's going to be your median. Or if over half the people give it the lowest score, that would also be your median. So the disadvantage of the median is that it doesn't only take the position of the values to account, not the values themselves. But once again, the nice thing currently is we have computers these days and spreadsheets which can find all these values easily. And so you don't have to just present just one value. You can always show. You can also find histograms and distributions to get an idea what the distribution looks like. So you have a better understanding what the center is and how to describe what the population actually looks like. Let's do one final example. This time I want to do a weighted mean. Okay, and give me to find my example. So a weighted mean. So we're doing an example of a GPA, so a semester GPA. Okay, let's say these are the grades a student has earned so far in class. So we just do little tables. There's our grade. And over here, I'm doing the hours of the course. I'm not really saying what the courses are, I was just making this up, but this is a good example. So let's say a student got an A in a 4-hour course. got also another A in a 3-hour course, a B in a 4-hour course, and let's say for some reason did badly, got an F in a 3-hour course. Okay, so we want to find the GPA, and once again, this is a weighted average because the grades are weighted. Let's top of the weights. I'll write that over here, what the weights are. Okay, so an A is 4 points, a B is 3 points, a C is 2 points. Then, as you expect, a D is 1 point, and then an F is 0 points. Okay, so the way the GPA does, what we do then is want to determine our points for each one of these classes. Okay, so we have 4 hours of an A, so that's going to be 4 times 4, which is 16. Okay, 3 hours with a B, so that's going to be 3 times 3 is 9. Okay, 4 hours with a B, so 4 times 3 is 12. And then finally an F. Okay, and so an F is 0 points, so 3 times 0 is just going to be 0. Now, what I do then want to sum these up, so sum up our hours. So remember this Greek letter sigma means sum. Okay, and that's going to be equal to, so 4 plus 3 is 7, plus another 4 is 11, plus 3 is 14. Okay, then we also want to sum our points. Okay, the total number of points for the semester. We do that. That's going to be 16 plus 9 is 25, plus 12 is 37. And then our GPA, we divide that. So GPA is going to be the sum of the points over the sum of the hours. Okay, so 37 divided by 14, and we just plug that in. And that is going to be approximately 2.64. As you can see, that F actually threw things off quite a bit, didn't it? So that's how I find a GPA. Okay, and once again, GPA is a weighted mean because each one of our values, okay, has, in this case, our value A has a different weight. Now, they all have the same weight, then we just be adding up the numbers divided by, that would come out very differently. But here, each one is weighted differently, so that's how you do a weighted mean. We're not may not see weighted means as much in this or other statistics courses, but it is useful to understand that as well. Okay, so that was right now for all on measures of centers. Let's go back and take a look at our goals. So we understood the measures of center and their strengths and weaknesses, what they do and what they don't give you. Also found how to actually determine how to find those measures of center with some examples. Okay. Thank you. Have a good day.